Saxon Algebra 2, Lesson 26. Yay, trinomial factoring is here. You remember how to do it. It's fun. Factor x squared plus 6 minus 5x. Notice that we are factoring expressions. There's no equal sign in this, so we're not solving for x. We're just practicing the process of factoring. All right, the first drama, is this in order? Remember, the standard form for a trinomial is ax squared plus bx plus c. That's for an expression. We'll talk about equations on another day. So we want to put them in this order. John is messing with us. So I'm careful not to mess up the signs. I just rewrite them. And now we know that when we factor this, our answer is going to be a pair of binomials, right? And the x is going to be in the beginning. And then we're looking for two numbers that will multiply to 6, positive 6, and add to minus 5. Remember, the signs are an important part of this. So we can tell by this that, for example, 6 and 1, that's not going to work. Because 6 and 1, they multiply to 6, but they don't add to minus 5. What about minus 6 times minus 1? That also multiplies to positive 1, but that doesn't get us, that gets us minus 7 instead of minus 5. All right, what else multiplies to 6? 2 and 3. That multiplies there, but it adds to positive 5. Okay, we're close. And then we try this one. These two multiply to positive 6 and add to negative 5. So this is our winner. And we copy the signs and the values into the parentheses. And happy days are here again. Remember? So our numbers have to add to the C term. No, multiply to the C term. Excuse me. Multiply to C. And add to B. That's the rule. With this being the code for what A, B, and C are. All right, and again, you can do these in your head pretty quickly, but if you get stuck or feel like this is just way hard, just try writing down the pairs of numbers you can think of that will multiply to this, and then test them to see if they add to that. Let's try another one. Example 26.2. Most students really kind of enjoy this once we get in the jam. All right. This one, okay, I was going to show you that this one's in order, but from now on, I don't even write them down in the wrong order, and you don't have to either. Just copy them the right way in the homework. But here's a little drama. Minus x squared plus 5x plus 14. Okay, one of the assumptions for this kind of factoring, at least now, later we'll deal with this irregularity, but right now, the A term has to be 1. We can only have just a plain x squared here. We don't want anything else in front of this x squared other than just that invisible 1 and a plus sign. So this minus is not happening for us at all. So what we do when we see something chilling in front of that x squared that we don't like, we factor it out. So I'm going to factor out a minus 1 because I don't want that minus sign there. So this will become positive. This will become negative, right? This minus 1 changes the sign of everything. And then this becomes negative also. Okay, so when I factor out the minus 1, it changes the signs. And this is an easy thing to test because if I multiplied back, I should get the first row, and I do. Okay, now we can just leave this minus sign out here, and I'm going to skip the 1. I don't need that. I'm just going to put the minus sign, and then my two binomial parenthesis sets. And I know I'm going to have x here. And now I'm just looking for my two numbers that multiply to minus 14 and add to minus 5. So I'm going to give you a minute to think about it, and then I'll tell. If you can think of it, just write it into the boxes. Or parentheses, they're not boxes. All right, I can tell it's 7 and 2. I know that one of those has to be negative. I can tell that 7 should have the negative sign because the sum needs to be minus 5. So x minus 7, x plus 2. All right, this is the way I would like to see the answer. What you can do if you want is distribute it. This is why it's confusing, and this is why I would prefer to see it this way. You can distribute this minus sign into one of the factors or the other factor. I don't like that. I don't even want you to look at it. That's the right way to do the answer. Just leave whatever you factored out, just leave it chilling out there. It's fine. Okay, more. Okay, here's another one John's got in a crazy mixed up order. I don't like it. I'm gonna write it down in the proper descending order. So it's gonna be minus 3x squared plus 6x plus 24, all right? Now, just like before, anything that's in front of my x squared term gives me a headache, and I'm gonna keep my fingers crossed, knock on wood, and pray to the gods of trinomials that there's only one God, so I'm praying to our Heavenly Father that I can just factor out that minus 3 and it will all work out. So let's try it. Minus 3, okay, I'm going to have x squared there. That makes me happy. What if I pull a minus 3 out of that? Then I'm going to have minus 2x. Again, this should multiply back if I did it right. And this will be minus 8. Okay, and then I'm ready to do my brain work here. It needs to multiply to negative 8 and add to negative 2. So I can see, I'll give you a second before I write it in. Right? Some students ask, could you write it like this? What if you write x plus 2 and x minus 4? What if you change the order of those? As long as the sign and the number are the same, right? Minus 4 and plus 2. As long as the contents of the parentheses are exactly the same, that's fine. Doesn't have to be in any specific order. In multiplication, order doesn't matter. So either of those would be lovely. 26.4. This is the last one of these, and it's a doozy. 32x squared plus 12x to the third, what? Minus 2x to the fourth. Okay, what in the world is happening here? I saw the squared and I thought we were fine, but then we went up in our exponents instead of down. So, number one, even if your powers are crazy, put the trinomial in order with the biggest exponent first. Get them into the proper order. Or get them going from biggest to smallest. Plus 12x to the third plus 32x squared. Now, back to the same advice I gave you up here. Pray that whatever you pull out to make this first one x squared will come out of the other ones just fine. John's kind. So I want this to be x squared, right? So that means I have to take out a minus 2x squared because that's to the fourth. So I'll leave 2 and I'll take 2. Okay, now I have to do that to all of these. If I pull a minus 2 out of here, I get minus 6. If I take 2 x's, I'll have 1 left behind. Right? And again, if I'm feeling wobbly, just multiply back and see. I get plus 12x to the third. Yay. And then here, it's going to be minus 16. Minus 2 times minus 16 equals positive 32. Good, I like that. And I'm taking out x squared, so there's no x's left. Make sense? So these are quite horrifying when we see them at first, but John is very kind and he makes them work out beautifully. Okay, so my crazy thing out here stays, and now I just set this up. I'm looking for two numbers that multiply to minus 16 and add to minus 6. Go ahead and think about that and write it in when you get it. That's the final answer. Remember that if you wrote x plus 2, x minus 8, that's equally correct. Yay! Trinomial factoring. Love it. Okay, second topic, final topic. We have one problem to do with this. Overlapping right triangles. All right, this is a slightly new twist. I think it's new. That is one downside of teaching all the different levels at the same time, which I love to do, but I can't remember who I've told what to. Overlapping right triangles. And I know I've told you my color form story. I'm pretty sure I told you that about those those sticker dolls that I used to play with when I was little. And this is kind of a version, a twist on that. Instead of having the triangles stacked on each other top to bottom, they're stacked on each other sideways. All right, so here is our diagram. I'm going to draw it exactly the way it is in the book. Copy, please. Okay, there's the shapes. Now we've got some letters coming in. Okay, beautiful. So the first thing we want to do, just like we did before, is we want to peel this little triangle off and draw them as two separate triangles. Pretend they look exactly the same as the original diagram. They don't. I'm exaggerating because I'd rather have them look more different than the same. So I'm going to copy all the information. Now that angle is the same, isn't it? And look, that angle is the same. Ooh, so I don't even have to do that parallel lines transversals like we talked about last time. I know for sure these are similar triangles because they have two matching angles. And so I know they're similar because angle, angle means angle, angle, angle. And if all the angles are the same, they're similar. Yay. All right, let's get the sides on here. The little one's always easier because we just pull those values off. Now this is C. This down here is going to be 10. And here comes the headache. This is A plus B. Okay, so I know that they're similar and I can go ahead and look for my anchor proportion. There it is. So I think I'd like to solve for C first because that's going to be easier. I can say that 6 over 10 equals 4 over C. I cross multiply. 6C equals 40. I divide by 6, and I get C equals, let's see, if I chop them each in half, it'll be 20 over 3. Okay, I like that. I mean, it's kind of ugly, but I can deal with it. And I want to look for the easiest way possible. I could try doing 6 over 10 equals A over A plus B. Let me just write it down. 6 over 10, that's my anchor proportion, equals A over A plus B. But that's not going to work, you guys, because that's one equation with two variables. So I can't solve that. You have to have as many equations as you do variables. So this is not going to work. So I'm going to look for something else. And what I notice is, oh, look, I've got two sides. I mean, I've got two sides here, but I'd rather do it this way. Pythagorean theorem, right? A squared plus B squared equals C squared. So I can say 6 squared plus 4 squared, and I double check to make sure, yeah, they're the legs, okay, equals A squared. So this is 36, and this is 16, which equals 52 equals A squared. So A equals the square root of 52. I don't have to say plus or minus because it can't be a negative length. Can't be negative. The length of this cannot be negative square root of 52. Okay. Well, that made my headache a little worse, but I didn't have a headache. But anyway, square root of 52 plus b. Ay, 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 right? Well, that's a mess, but we can do it, right? So we'll take this, and this is a great example of why not to erase or scribble it out too much. We can use this, but now that we know that a equals square root of 52, we'll plug that in. So 6 over 10 equals the square root of 52. Do you want to cry? I might. Square root of 52 plus b. Oh my word. Now we cross multiply, and I'm going to go up over here. So 6 times the square root of 52 plus 6b equals 10 times the square root of 52. It's a little squishy, sorry. All right, let's subtract 6 square root of 52 from both sides, because those match, right? That is the glory of what happened there. I hope you can see that. That's square root of 52 here. When I write it bigger, now you'll be better. This cancels, and I get 6b equals 4 square root of 52. Oh. Suddenly it doesn't seem so hideous anymore. Maybe I'm just used to it. So there's our b. Let's divide both sides by 6. 4 and 6 will cancel down. b equals 2 times the square root of 52 over 3. But 52 should factor out a little bit. 52, I know it's 26 times 2. And 26 I can break down into 13. So it should be 13 times 4. Yes, that's right. So we can pull out a pair of 2's. They'll make a single 2 over there. So my final answer is b equals 4. That's what's left. Square root of 13 over 3. Did we get it right? Let's check. Yay, that's right. C is 20 over 3, yes, and A is square root of 52, yes. So, are those ugly and obnoxious? Yes. Are they hard? Kind of. Look for an easy way to do it. And if you end up with this whole mess, if you end up with that, don't scratch it out. You're going to use it later. Just see if you can figure out A or B. It's usually A, depending on how the letters are set up. But there you have it. There are one of those. There is a problem like that in the practice. I really do want you guys to do all of the practice problems. If you've got the answers for them in your solutions manual, I really want you to do all of them. Because in the practice, it's so important that you get those new concepts locked in. So if you're not doing all of the practice problems, please start and don't hate me. Okay, that's all. 26. Goodbye.